Cool. Leah, I'm going to have you kick us off because I think, or actually, should we be discussing homework first? I don't know. Let's talk about homework, I guess. Sorry, I'm a little scattered today. Um, I'm interested to hear, did anyone actually start any trainings last week, or did anyone find other things that they thought were cool this week that they want to share? I think there are a couple projects in Slack. Does anyone want to talk about those? Peter, do you want to talk about the Deep Dream stuff you worked on?
Sure. Um, Leah helped me yesterday with Deep Dream. Um, yeah, I was having a lot of fun. Super fast because the training was going really slowly for the stuff I was doing the week before. But yeah, I was having just a lot of fun, like generating out different images. Um, I definitely want to read through the paper, the original paper, and yeah, see what else I can come up with. I tried sort of deep dreaming, like taking one of those images and putting it back through. And it didn't do a whole lot, so I want to experiment with that a little more. Um, yeah, it's fun.
Cool. Yeah, the images look really cool. I guess you're just playing with different layers. Is that right? This is like
Yeah,
an early
yeah.
layer. Yeah.
Yeah, the strength the same, and yeah, I just had the different layers going, and I wasn't sure how many layers are possible, but I kind of just added in a couple numbers just to see, oh, maybe there's a layer 6. Um, yeah, kept going with that.
Cool. Thanks. Peter, it looks like you started doing some stuff with images. Oh, and it looks like you got your grid thing working. Is that right?
Yep. Um, yeah, I'm still. That was just using the StyleGAN2 notebook. I'm curious to figure out how to get that grid. Now that I know just like some of the code with like maybe just working between like set images.
Hmm.
Yeah, it was fun to like just get that grid because I've been seeing it a lot. And then I did some stuff just like kind of the latent spacewalk and the StyleGAN2 notebook. But I had trained that. Sorry, I had trained we like the on a data set the video that we were kind of talking about like last week or something. But I couldn't get my pickle file into the StyleGAN2 like to set it up as a model.
Hmm.
So I need to like look at that again. But
Yeah. Yeah, let Leah and I know, and we can probably try to help you with that. Cool. Did anyone else get to mess with any of the other notebooks they saw? All right, take that as everyone being a little bit shy in the last week of class. Um, so yeah, so let's kick off a bunch of StyleGAN work. So I think Peter, this might help you a little bit as well with some of the stuff you're working on. So Leah, I guess I'm going to have you kick us off.
Yep. Okay, yeah, so for today, oh, hold on. My mouse is wonking out. Um, a little bit of technical difficulties. Okay. Looks like the slides are loading. Can you guys see my Google Chrome screen share right now?
Yep, we can.
Okay, cool. Yep. So today we're doing like all about StyleGAN2 and sort of focusing on different things you can do with StyleGAN. Not training per se, but working with pre-trained StyleGAN models. Like there are a bunch of them on the internet that you can work with, and sort of like figuring out like once you have a network, a StyleGAN2 network that is trained already, what different things can you play with it? Like how can you like use it in these different creative ways? And yeah, once again, yeah, our Calendly links are in Slack, and you should be scheduling one-on-ones with Derek and I if you want to. So yeah, I'll start off today talking about StyleGAN2 latent spaces, which is sort of like an underlying concept in how StyleGAN2 operates, which is it comes up in like manipulations you'll do with it, and it'll help with your understanding when you're manipulating StyleGAN2 models. And then I'll dive into a StyleGAN notebook, which I'll demo Inference, which is just generating new images from a model that's trained. And then Interpolation, which is those, like that video that Peter just showed of the faces morphing into each other and how to do that. And then, we'll take a short break, and then Derek will do sort of more advanced manipulation of StyleGAN2, like kind of pushing it further. I think it might be audio reactive stuff. And then, and then we'll talk about how to send you guys off because it is our last class. And yeah. So all about StyleGAN2. So StyleGAN2 is this model which has a thing called a latent space. And you can sort of envision a latent space as this, it's just like a physical space. Here we've shown it as like a 2D grid, which has a lot of points in it. And what StyleGAN2 does in the process of its training is it sort of figures out what this latent space looks like. So you can imagine you have your data set, which is, I don't know, this very amorphous cloud of stuff. And your model as it trains is essentially trying to figure out what that like amorphous cloud of stuff looks like and figure out like, okay, how do I say like this cloud is this shape with, basically it tries to like figure out what your data set looks like in terms of this latent space. So more concretely, like each of these points in the learned latent space after it's trained will correspond to a particular image that it generates. And so this latent space is the space of all possible things that your network can generate. So one point here might correspond to generating this image over here. And a point over here might correspond to generating this other image over here. And so one property of this latent space is that points that are close to each other will be pretty similar in terms of like what they look like. So here you can see there are these 2 points which are next to each other, and one, like they look pretty similar, although one has like a little bit of hair missing, and slight differences in like the hair and the bangs, but overall pretty similar. And so the really nice thing about this latent space is that it's pretty smooth. Like every point in it will correspond to an output generated image. So you can do things like interpolation, where you pick 2 points, and then for every point along like the line between those 2 points, you say, I'm going to generate each of those images, each of those frames. And then that's how you get that morphing effect, because it is a smooth latent space. So this is a sort of an oversimplification because of the fact that we're showing you 2 dimensions, just so our heads can wrap around this concept. But StyleGAN2 actually has 512 dimensions in its latent space. So pretty hard for us to conceive, but essentially for StyleGAN2, it's just a vector, like an array of 512 numbers that, it can like sort of change each of those 512 numbers to pick a particular point in that vector space. So each one of these points, like over here, or these points that I'm showing you here, actually corresponds to like a vector or an array of 512 numbers. whereas in an XY 2D space, it would just be like two numbers. But yeah, that is it for a latent space. Do you guys have any questions so far? Okay, I'm going to go on to the StyleGAN2 notebook, which is sort of it's an amalgamation of all these different things you can do with a model that's pre-trained. Yeah, it contains a section for inference, which is just generating new images, truncation, which is a parameter which will control how realistic or crazy the outputted generated images are. It also contains code for interpolation. So doing that like the smooth face morphing. And there are two different types of interpolation in that notebook. And then, yeah, also has code for mixing seeds, which is sort of you pick two points in that latent space and you figure out like, if you added those 2 points together, what does the outputted image look like? So that's kind of if you have like one image and another image and you want to mix them. And it also contains a section on projection, which is when you input, you grab some random picture from anywhere, doesn't need to be in your data set at all, and you figure out what the closest image in your StyleGAN2 latent space is. So what that'll look like is you, I don't know, input a picture of a cup, and then the cup will, through the process of projection, like slowly morph into like a face if your model is a face model. Yeah, so this is the notebook. So it has all these different sections for inference and truncation and interpolation and so on. Today, I'll just go through inference, truncation, and interpolation, linear interpolation. And yeah, we'll leave mixing seeds and projection if you guys want to explore it even more on your own. Yeah, so so this first cell is to, like as usual, just set up your environment, download the StyleGAN2 repo, which is here. Oh, oops. I'm gonna reset my runtime just because I previously run this. Let's start fresh. Reconnect. I'm not a robot.
I think earlier this year, Leah and I taught a class that was all about StyleGAN. So we have like 2 full lectures on doing both this as well as some other stuff that we'll talk about later. So if folks are interested, we'll link to those videos and you can dig in and ask us any questions in either one-on-ones or in Slack.
Mm-hmm. Yeah, we have a lot of material regarding StyleGAN2. Yeah, so let me run this first cell, which will go ahead and install the StyleGAN2 repo. There it is. And yeah. I'm gonna run this cell this is just a cell to display images within Colab. And here, this cell is where you define what model you want to play with. So here, this Google ID points to the FFHQ, the FFHQ model, which is like the typical faces model. But going back to the slides, there is this repo that Justin Pinkney compiles, which contains a lot of, where people will just sort of be like, I trained this network, and then send it to Justin and add it to this repository, which is an ongoing list of models that people have trained and are like, I want to share these with people to play with. So yeah, I know Derek has contributed this abstract art one. And yeah, one important thing when you're scrolling through this is that you should pay attention to the resolutions, because not all of the things in this repo are 1024. Like this one is 512 by 512. There are some that are, this one's also 512. There are some that are 256. So yeah, pretty important, as you know, in terms of like neural networks knowing what size your input images are in your data set, because they're pretty rigid in that way, in that, yeah, the resolution of the data set restricts the resolution of what they can generate. So yeah, let's go ahead and play with this one, which Derek trained on this artist, Freya Buckler's work. And so here I can go ahead and just grab this ID and take it and put it over here. Oops. Delete and add. Yep, and there it is there. Cool. And yeah, so now let's move on to inference, which is just taking this network here and seeing what images it can generate. So this is the command. It's just an exclamation mark Python run this script called rungenerator.py, which will be a script in this repo. And tell it to generate images. This is a parameter which should point to your path to your network. So yeah, here this is fine, but yeah. There's this thing called seeds, which goes back to the latent space that I was explaining earlier. Here, a seed corresponds to a particular point in the latent space. So maybe this point here corresponds to like seed 18, and this point over here corresponds to like seed 50. And then maybe this one's like seed 23. It's just sort of the seed stands for like a random seed, which just means take this number and pick a random vector that corresponds to it. But yeah, essentially each seed is just a different random point in this space. So here we're telling it to take a seed, which we just identify as seed 18, but just essentially just means pick a random point. Yeah, so running this command will generate one image, which will be the image for seed 18.
Oh, just one thing to note, Leah, you might want to change the truncation PSI.
Oh,
because it's at 0 right now. We'll get to truncation in just a minute, but if you set truncation to 0, you will always get the exact same image. So regardless of what seed you use, you'll get a different image. Yeah.
Yeah, good point. Maybe like a 0.5, 0.7. Yeah, so truncation is this value, or it's like a parameter for StyleGAN, which controls how realistic an image is. It's a number that ranges from 0 to 1 for each of these points. Each of these points has its own random seed, which identifies the point itself. But then also with that point, you can specify any truncation value. So the truncation value might be like 0.7 or 0. And that will like given the same seed, will give you sort of the same image, but more realistic or more like unrealistic and crazy looking. So yeah, we can go ahead and see what we got. Seed 18. So this next cell is just a cell to display the images that we saw. Let's run that. Ooh. There we go. That's seed 18. Maybe let's try. You can also, one thing for the seeds command is if you want to generate like, I don't know, like 50 images or 100, you can just type like 1 through 50, and this will know that you mean like 1, 2, 3, all the way up to 50. And if you run this, it'll create a folder with 50 generated images in it. So you can use that if you want to just generate a whole bunch. Yeah, and there they are going. See, 1, 2, 3, 4. Yeah, and also as you know with Colab, you'll need to zip this file in order to download it and like grab all the files rather than like, you don't want to go through each of these individually and click download, download, download. You can just run this command to zip this folder and download it in bulk. So I would grab this path and put it in here. And this is the name of the zip file it'll create. Generally, it's like good practice to include your truncation value because, yeah, to just sort of keep track of your truncation value in case you want to regenerate the same images, because these file names have the seed number, but not the truncation value saved in them. So yeah, in order to generate exactly the same image, you need both the seed number and the truncation value that you generated with it. Any questions so far? Okay. Yeah, so just what did we do just now? Inference is just taking a model which you've trained already and then using it to generate a new image or set of new images. So that's literally just picking like random seed number 18 and generating its corresponding image. So inference has a lot of different names. It's also called evaluation. It's also called testing. But yeah, they all just mean generating new images from your trained model. So yeah, moving on to truncation, which we just touched on. Less truncated is like corresponds to the image being less realistic. So this is an example of truncation for the same random seed, but the truncation value sliding. And this is on the faces model. So this, I think, starts at truncation 0 and then increases the truncation value.
Yeah, so truncation values like technically don't have any limit. Like you can go from like 0 to 5 or 0 to -5, and it just gets weirder and weirder and weirder the further out you get. So most people generally keep it between 0 and 1. But if you want to play with it, you can generate some really, really weird values as well.
Mm-hmm. Yeah, truncation value of 0 is sort of like, this is the most realistic, or I don't know, like it's kind of like the base value. So I think is it true that for any random seed, if you have truncation of 0, it'll be the same?
Yeah, so you can actually imagine this for those of you who are more math friendly. It's a distribution. So basically, if you set to 0, it's basically saying it's like the most center, median, average value, and basically the wider you make it, the more of an average distribution you get. So it's basically like sort of compressing into your space a little bit in some ways, which is why they call it truncation.
Mm. Yeah, so this is the face with truncation 0. And so if you picked any random seed and set the truncation to 0, it would be this particular face. So we can go ahead and check out truncation. Let's go to truncation. So again, run generator.py, the script. We're telling it to do a truncation traversal. And yeah, we can pick which random seed we want. a particular workflow that like I generally do is you generate a whole bunch of seeds and then you download this folder and you're like, you flip through them and you're like, oh, I really like seed 5 or seed, I don't know, 12. And you say, yeah, and then you just figure out which seeds are like good that you like and you go ahead and use them. And yeah, so this truncation traversal will be similar to that video from before, where you, for one particular seed, you decide, you tell it which truncation value you want to start at. This is currently set to -2, and it'll stop at +2, and it'll just increment in steps of 0.1. But yeah, maybe for today, I'll make it a little smaller for the purpose of time. We can run that and see what we get. So this, yeah, so this will start at -1, which means it'll be, like, since the -1 is far from 0, it'll be, go from weird and crazy to like normal when it hits 0 and then become more weird later on. Whereas the other video you just saw started at 0 and like went in one direction. And these should be stored in this truncation traversal folder. And we can see all the frames being generated. Yeah. And so it's starting at -1, going in steps of 0.3, which I told it to do over here, and just scrubbing the truncation value. And then once that's done, there is code to just take all these frames and splice them into a video. You can, yeah, looks like it's passing through 0 now. And yeah, for this one, I'll need to change this path to this 0002. And this frame 05D, the %05D just says my frames are named as things of 5 digits long from, yeah, starting at 1 and going up. And yeah, I think we can, I'll just run this now with what we have and we'll see what we got. Let's see.
Do you have to run the command above it where it's like defining the list of image names, or is that just if you want to view the images?
Yeah, this is, yeah, that's right. This is just if you want to like look at some of them. We can look at a couple, but this is just like for your own examination. If you don't want to like go ahead and download some of them and check them on your own computer.
I think what's happening is the truncation hasn't actually stopped in the cell above it, so it's still running.
Oh, you're right.
But you're almost there, so you might as well just like. I find that stopping cells inside of Colab is sometimes like a little weird. It like doesn't happen the way you expect it to. Yeah. Yeah, it looks like it's running now.
Okay. Cool. Yep. So now we have this truncation example. Let's check it out. Downloaded. I might need to stop sharing my screen because I think. Okay. Sorry. My laptop is being weird today. Okay. Let's open this MP4. And you can see what will happen. Let's replay that. Oops. So yeah, over here is truncation value -1. Around here will be the same image we generated earlier at like truncation value 0. And then over here is the truncation value at 1. Yeah, it's a little hard to tell with like abstract art that like the image at the beginning and the image at the end are like the weirdest, and that the middle one was like, I don't know, the most average or like similar to the original training data set. But yeah, if you do faces, it'll definitely come out that like the faces on the ends will look like really weird and, I don't know, kind of grotesque.
Can you make these videos loop?
For truncation, since truncation is like a value along like it's a one-dimensional value. Like I guess if you wanted to loop, you would need to go like in one direction and then come back. Whereas, yeah, this is, yeah, just taking a start value and then going to this value over here. So if you wanted to loop it, you'd probably like reverse it. So yeah, that is truncation. And the next thing you can do with StyleGAN2 is interpolation, which is sort of that stereotypical StyleGAN2 morphing thing, similar to, or like what Peter showed at the beginning of class with the faces being morphed into each other. What interpolation actually is from the linear or the latent space perspective is you're taking a couple of random seeds. So here we're picking 4 points, and this might be like random seed 12, 18, 5, and 7. And you pick some seeds and it smoothly interpolates between each of the points you've picked. And this you can make looping if you just wrap it around. If you're like, I want to start from 5, 12, 18, then go back to 5. That'll be a looping video because it'll go back to 5 at the beginning. The way the code is written is that for each of these legs that it interpolates between, it'll generate an equal number of frames. So maybe it'll generate 10 frames for this leg, but also 10 frames for this leg as well. And a side effect of this is that this movement will appear to be slower than this movement because this movement covers a longer distance, but still has the same number of frames. Yeah. There's also a different kind of interpolation called a noise loop, which you can picture as you just pick one seed and then the code just sort of picks this random walk, a random loop, using something called simplex noise, which just sort of determines like how that randomness occurs. But it will start from the point you defined or the point you picked, and then it'll just walk around randomly, go through a lot of different points, and then come back to the beginning. So with this noise loop interpolation, you have control over your starting point and then a thing called diameter, which is just like a number that corresponds to how big this loop is. Sort of very hand-wavy term. So yeah, let's go ahead and do interpolation. Interpolation. So this section is for linear interpolation, where we pick some seeds. So those seeds are the same as these seeds over here. So maybe I have previously decided that I don't know, like seed 5, 18, which we saw. Or maybe we'll start at 18. 18, 5, 10, 12, 18. So this will be looping because it'll come back around to seed 18. And for all of these frames, it will generate them all at one truncation number. So yeah, you will pick one truncation value, and that will be like the truncation value for all of the images generated. And you can also specify how many frames that it'll generate between each of those seeds. So here we've set it to 100, but you can change that to something else. So yeah, you can see it. Since we've input 5 of these, so yeah, it will be generating 104 frames. And they're here. You can see it stepping through all of them. And then this cell right here is just a cell to go ahead and take all those frames and smush them together in a video. So I can go ahead and make sure this path here is correct. It will be 003, since this one's called 003. And it'll be saved out as line Z walk. Let's run that. Running. Let's refresh. Line Z walk. And download it. And we can see. So this will be those 5. This will be an interpolation between these 5 seeds here. Let's see what we got. Yeah, so this is a truncation one. This is it. Yeah, this first one should be what corresponds to seed 18. And you can see like as it plays, it sort of like moves and then sort of pauses pretty briefly on a particular seed and then will move again and then pause briefly, sort of having these like inflection points in the video. Yeah, and if you want, like this is moving pretty fast. I think if I were doing this again and wanted to make a slower video, I'd bump up these frames. But yeah, just keeping it low for today. Yeah, and so the slides contain the link to the notebook, which has these other bits too on mixing seeds and projection, which are just later sections in this notebook. But it'll walk you through how to do it.
I also just added links to our class notes so that you can see there's 3 weeks of videos of this plus some other things that we'll be discussing later. So you can also go through those videos. Those are like an hour and a half long each. So if you're interested in seeing us explore like the noise loop and some other stuff, or just want to walk along with us in those, you can check out those videos as well.
Mm-hmm. Yep. Yeah, and that's it for my section, unless you guys have any questions about what I demoed?
I just have one question about is W space, is that just like another vector or like dimension compared to Z, or is there anything like notable that's different about them?
Yeah, so the W versus Z space is kind of a complex topic. There's a video, I believe, the week 3 video that I just added to our class notes. Check that out for a little bit of a better explanation of what goes on. But essentially, the W space is probably better to use if you can. More than likely, it's what we call less disentangled, which means the interpolation will feel a little bit smoother. So in general, use the W space when you can, but it's not always a thing that's possible. And there's like kind of a complicated reason for that. But yeah, essentially, they're different. The way that StyleGAN works is the W space is is a different mapping network of how the Z space works. So it's just a slightly like, it's basically meant to be, so the Z space essentially could have big gaps in it depending on how things are trained, and the W space helps smooth that out, so everything is a little bit cleaner, but there's still maybe gaps sometimes, so you have to sort of watch as you make those. So in general, I would say like start with the W space and like maybe make animations of both and just sort of see how you feel about each of them, because you know, the one thing is W space being less entangled is better. It creates a more smoother animation. But from like an artistic perspective, there's less noise in it. So maybe sometimes you want a little bit of that noisiness as things move through these spaces. So they're pretty minor and pretty subtle most of the time in terms of effect, but I would definitely recommend playing with both of them.
Mm-hmm. Yeah, and adding on to that, like all GANs have Z space, and then W space is something that people added to StyleGAN2 to disentangle features, which just sort of means that the Z space is sort of like a bare representation of your training data, like its distribution. And then like your network might learn features that sort of don't correspond directly to the distribution of the training set. And then W space people added on to StyleGAN2 to like take each of those features and define them into more, I don't know, things that would make sense to a person. So for example, if you're interpolating between like, I don't know, a man and an image of a lady in both not, if you're interpolating between a man and an image of a lady in the Z space, like you might get like random features that like you or I wouldn't think make sense. Like maybe for like a split second, like the guy gets glasses when there's no reason to add in glasses in there. But yeah, the W space will generally like rip out things that are not necessary, like the guy getting glasses in the middle.
Disentanglement is like a really complicated topic and something we're not going to go into this class, but there is a whole lecture around feature vectors, and that's a way to look at how to do disentanglement and other things. So if you're interested in another hour-and-a-half lecture, there's definitely a video for that to check out. Cool, so why don't we take a short break? So let's take a 5-minute break and then we'll come back and look at a bunch of other notebooks to do some more advanced, it's not even necessarily advanced, just different, different stuff. So let's come back at 25 after. Sound good? Cool, all right, see everybody in 5 minutes. One second, looks like I have to set something up here. Were there any other questions about the Z or W space or anything about what Leah was presenting? I included a link to a previous class that Leah and I taught, a whole video around W versus Z space. All right, everyone is very quiet today. Okay, so we're going to cover some more, like I guess you could call this advanced techniques. Essentially, like the difference between these notebooks and the notebook that Leah showed you is, the notebook Leah showed you is basically stuff that comes almost pre-packaged with the default StyleGAN repo. I've made a couple modifications to that particular repo in order to do the truncation traversal and a couple other things. But by and large, that's stuff that just comes with the StyleGAN2 notebooks. We're going to look at some notebooks made by other folks who have done some more like weirder stuff or just like are playing with different things. And we'll talk about what each of these notebooks does. And then eventually, like we'll get to manipulating those vectors, because those vectors are just mathematic numbers. We'll look at how to manipulate them using audio, or, you know, this will be an example of how you can manipulate them using anything. So just like we did with Deep Dream, it's important to remember that, you know, all of these models, these machine learning models, or probably pretty much any of them we've looked at in this class, are what's called deep learning. And that deep learning just refers to that they have these layers of networks, right? So just like in Deep Dream, where we explored changing the layers to get different structures, with StyleGAN2, it's also a layered network. So this is like a very complicated drawing of how StyleGAN, this is actually StyleGAN1, but it's fairly similar, of how StyleGAN works. So actually, like where we were discussing that W space, that W space exists here. The latent Z space, which is like the sort of mathematics space, exists over here. There's this crazy like mapping network that basically translates things into a W space, and then those W spaces get input at each of these layers inside of these blocks. You don't need to know what this means, just know that like this is, StyleGAN is much more complicated than a lot of other networks that maybe we've dealt with in the past, but this also allows us a lot of opportunities to play with different things. So again, the Z space exists sort of naturally inside the model. The W space is sort of a manipulated space inside of the StyleGAN network in particular. What's also important to remember is that there's sort of this what's called upsampling block, and this upsampling block happens if you're using a 1024 resolution model. This happens 16 times within StyleGAN. So you'll often hear people refer to layer 1 inside of StyleGAN or layer 16 inside of StyleGAN, and that refers to these upsampling networks. So when you start with what's called a constant layer. This constant layer is like a linear value, and then you pass it to these upsampling layers. So this goes from like 4x4. So they start at very small pixels, right? They start with like 4x4 pixels, then 8x8, then 16x16, 32. It's sort of like, if you've heard of this referring as like progressive growing. The history of StyleGAN2 is actually that it started as progressive growing, and then it became this like new model that has actually dropped progressive growing, but the idea of this upsampling layer still happens. So a lot of times, you know, you'll hear layer 1, layer 2, layer 3. Each of those corresponds to sort of a pixel value. All that's to say, like the most important thing to know about that is that lower layers, so layer 1, 2, 3, 4, 5, control what we would call a global structure. That means, you know, in the case of faces, that means your body, the face shape, like the overall like sort of silhouette of your shape, maybe shoulder structure, maybe some other things. Whereas higher layers control more details and fine textures. So when you get up to like layer 14, 15, 16, it's almost like just playing with like hair details and like, you know, does the hair like bend out or in, or like is there a little bit of highlighting in it, like those sort of things. This is the most important thing to know about the layers of StyleGAN, is that early layers control big global like, you know, features, and higher layers control these like finer textures. Because you'll see this as we look at a couple of these notebooks, like you'll see these manipulated, and that's sort of the thing to remember about these. So here are 4 notebooks that are worth playing with and worth looking at. For each of them, there's also a demo video. I don't want to like, because each of these is almost a full class in and of itself to demo, I definitely recommend, if you're interested in playing with some of these, to watch the demo video while you're also playing along with the notebook. So there are 4 of these here. And these are 4 that I generally use quite a lot. So flesh digressions, which I think is one that Peter, you've already started working with, while also having just like a really very metal name. It is essentially what it does, it does a loop in the constant layer and the style layer. So that is, it generates like, if you've done stuff with like generative art, it generates like a circular sine cosine loop at this layer. And then it also does it in the style layers, which are here. And I don't know, I think it might do it at this style layer. I don't actually remember exactly what style layer it works at. But essentially what this does then is it creates like, most of our models are used to seeing very particular like there's a very narrow range of constant numbers that it sees. So what this does is it really screws up like sort of what the model is expecting to see. So this flesh digressions thing, which I think is what Peter showed, where like faces start appearing, it creates really weird looping effects. And if you use the notebook by default, it does create a continuous loop. So it's worth looking at that. There's also different features in there to play with sort of like how wide these loops are in each layer. But this will produce some really interesting things. And all you need to know about this is that like, you don't actually need to know what's going on behind the scenes, but it's helpful to know that like you're playing with these constant and style layers within the network. This one you can play with pretty quickly. It takes a couple minutes to really mess with. The next notebook to look at is GAN space. So this describes this thing called feature vectors. Feature vectors are the idea that, let's say we have a face or the face model, and we want to learn how to convert the same face, and we want to change the eyes from blue to green, right? We should be able to do that because the latent space knows a lot about blue eyes, green eyes, whatever. Unfortunately, like out of the box, you don't get that sort of like capability, right? The machine sees stuff very differently than we as humans do. So what you have to do is do what's called finding a feature vector. And there are many, many different techniques for finding feature vectors, but GAN space is this kind of nice one in that you don't need to do a lot of like work yourself. A lot of what people used to do to find feature vectors is they would actually like generate a bunch of images and they would tag this one has blue eyes, this one has green eyes, and then they would like generate the latent space and draw like a line through that latent space to figure out like what is the map of blue to green eyes. That is a very convoluted and time-intensive process. What GAN space does, it uses a thing called PCA, which you don't need to know what that means, but GAN space essentially allows you to upload a model, and then it will try to learn the biggest feature vectors or the most important feature vectors by itself. This process takes about an hour or two, depending on what you're doing. So just be aware that this will take a little bit of time, but I do have a video of actually where we take those feature vectors we find and then we can manipulate them using audio reaction or other things. So there's a demo video of how to use that here. Network bending is a pretty cool library that, because each of these layers stacks on top of each other, if you do a manipulation, like say you take your first layer, which is like very early and very global structures, and you begin to rotate it, what happens is at the higher layers, you also get these rotations. But again, because these models are often used to seeing things in very like strict patterns, as you begin to change those layers, you get weirder and weirder things happening further up your layers, layer stack, I guess is what I would call it. So this one can do some cool things where you can do a bunch of different techniques at each layer, and you can choose what layer you want to do. So you can do stuff like rotate the image. You can do stuff like what's called ablation, which is basically you like zero out that layer. You can do other things. What else can you do? You can do mirroring, you can do translation, you can do a bunch of things to mess with these layers. And what happens is if you do them in the lower layers, you get really big changes. And if you do them at the higher layers, you get like more finite changes. Really cool stuff. And there's also a way to do feature vectors from this library as well. So if you can start to manipulate features, like say, I think the example that the person who made this library has is that if you can find the eye vector, right, the vector that opens or closes eyes, or even just generates eyes, you could also zero out that vector or those weights in the model, and that would actually like remove people's eyes. And yes, it actually removes people's eyes. It's very creepy. Or you can like scale up people's eyes, and then they have like big anime eyes. Really cool stuff here. And this is like, I think the person who made this, Terry, is probably the only person who like has actually really explored a lot of this. I've started to explore a little bit of it, and I know maybe a handful of other people who have really explored this model, but there's so much you could do in this. Like you could spend a year just exploring this thing. So really cool stuff. And then this, maybe 2 weeks ago, Justin Pinkney, the guy who has the awesome pre-trained StyleGAN2 model, started sharing some of the work that he's been doing, which is called network blending, which is different than network bending, but network blending, which actually takes two different StyleGAN models. And what you do is, because these are structured the same way, but have different weights inside the model, you can basically say, I want to go from layers 1 through 4, I want to use this model. And then when at layer 5 and up, I want to switch to a different model. And you get really, really weird stuff. I started producing some things last night here. Let me pull this up really quickly. Just sort of show you like, this will produce creepy things for sure. There's lots of ways to produce very creepy things in StyleGAN. Let's see if I can find one here really quickly. Here we go. So those of you who are familiar with my bone GAN, this is at the very beginning, this is human FFHQ. So this is human outlines of shapes, right? So you can see this guy is clearly wearing a hat, and then it like adds on bone. Like, so this is layer 1 is FHQ, and everything after that is bone. So you get these like bone distorted into very weird human silhouettes. And then this example is a little bit later in the network. So this is, I think, you know, maybe layer 3 or layer 4. So you go FFHQ up to layer 3, and then after that you pick up bone. So you get like these furry faces. Really interesting stuff. And this is like the beginning of like really powerful tools we could begin to use inside of StyleGAN. So this is another really good notebook. I just recorded a demo of it last night. Justin did a good job of documenting a lot of stuff, so you could probably just walk through it and understand a lot of it yourself. But if you are interested, there's a demo video as well. So lots of cool things to play with here. And again, I would say like literally there are like a handful of people like playing with any of these at any one time. So if you get into it and you spend like 2 or 3 hours on these things, you're probably doing more work than anyone else in the world has yet. So lots of opportunities for really ripe playing with this stuff. And Justin has done a bunch of really funky examples. Actually, hold on, I have to show this. This is like one of the coolest things I've seen using StyleGAN yet. So let me see if I can pull this up. So Justin has started doing, I'm going to butcher the name, Yukio, or however you pronounce it, like a Japanese animation style or a painting style. So basically, what is it?
Ukiyo-e.
Okay, thank you, Naoko. Perfect. So basically there is a StyleGAN model that's freely available that does that. So like the very early layers are that, right? So you get these structures of those paintings, and then he adds FFHQ on top of it, which gives you like a realistic human texture to things. So just really, really interesting stuff. There's another person, I believe, Doran Adler, who has been doing some similar work, but this is with taking like cartoon faces and then applying FHQ at later layers. So you get this almost like Pixar, like 3D rendered cartoon. So just some really, really amazing and interesting work that could be done here that I think is really worth playing around with. And this is like starting to show the power of like StyleGAN outside of just the basic StyleGAN networks we see. Okay, cool. Now that I've talked for 20 minutes about how cool I think these things are, putting all that aside for a little bit, let's take a look at how to do audio reactions. So one of the things that's really important to know is because these latent spaces are just numbers, right? Like they're numerical values. It's a 512 dimensional vector. You can manipulate that value using any other sort of mathematic process, right? So we're going to look at audio, but you could easily use like a keyboard or a joystick or other ways. You know, maybe you attach it to like some sort of you know, Arduino or something to like track, you know, weather patterns or other things where you have a mathematic value. And the idea is just that you need to map that value, and hopefully it's like a 0 to 1 or something you can map to 0 to 1 to some of the StyleGAN's model like innate data. So the way it works is like, you know, StyleGAN has these innate structures sort of in it, whether it's latent space, which goes from -1 to 1, truncation. You could, if you use the feature vectors you find inside of GAN space, you can begin to manipulate feature vectors, these sort of things. So there's a bunch of like opportunities here to begin to play with these things in a really, really interesting way. And again, now it's just not just like the model, it's like now the model plus some generative art techniques or other ways to manipulate things. So we're going to look at this audio reactive notebook. This is, again, going to be sort of just like a toe in the water of like all these things we could do. But I think there's a lot of opportunities here to play with this. Cool. So let's take a look at this notebook really quickly. And so there should be a link to this already set up. And we're going to skip most of the second half of this, but I'm just going to walk you through sort of the process. I think it's also helpful to sort of see another notebook that handles things a little bit differently than you might be used to or might have seen before. So first thing we're going to do is we're going to connect to our network. We're going to install this stuff. And in this case, I think let's just use FFHQ. You know, I don't love doing art projects with FFHQ, but it is easy to see sort of what's going on because all of us are tuned into how human faces work. So we're going to download the FFHQ pickle file. You're also always welcome to use this ID. I think this is a file that I have in my Google Drive. It'll probably never disappear, so you're always welcome to do this and use this if you're interested. Cool, so now we need to upload a audio file. So this, there's two ways I could do this. I could run this command, which is just gonna add a little, a sort of like file uploader, or I could just drag and drop my file up here. So I'm actually just gonna do the drag and drop. Tends to be how I work. I'm gonna grab this little like vocal file. If you're looking for audio files, I generally recommend like Googling like audio stems or something, and that will give you like remixable files, and usually those are separated out. There's also a video that Leah recorded, which uses a thing called demux, which actually is like a machine learning model that separates out layers from audio tracks. So you can try that and see how that works for you. I find it it's less useful than maybe like finding raw audio stems, but there aren't a lot of audio stems that are around the internet for songs you might want to play with. So use that if you're interested. Okay, so now this is uploaded. So now there's a couple of things I want to set here. Just want to set some variable names. So I'm actually going to change this to being this path. And then we're going to set frames per second. So frames per second is basically going to look at our audio samples in a number of, you know, this many audio samples per second and give us the volume value of that. And then that'll also help generate that helps determine how many frames we're going to generate. I'm going to set this to be a lot lower just because we're doing a demo. So we'll set this to be 24 frames per second. So I'm going to run that command. All right, so now there's a ton of code here. And I think the important thing to remember is like, you're welcome to like go through this line by line, and you can probably debug if you're familiar with using audio, you know, in maybe like Python. This is pretty straightforward. But essentially what we're doing here is we're going to take the audio from this file and we're going to break it up into a bunch of different segments, and we're going to track the volume at each of those segments. So basically what we're going to do is we're going to take the sound, we're going to normalize it, so it's like 1 is always at its loudest point and 0 is always at its quietest point. And then we're going to use matplotlib to actually plot the graph of this. We'll be able to see sort of what we're going to expect here. So yeah, I won't go too deep into this. If you're interested in understanding what's going on here, I'm happy to walk you through it. But essentially all we're doing is we're generating little segments of audio and determining the volume at each of those.
I think the video that you shared, sorry, a bit ago using this technique, but it looked like it was almost the mouths were moving in correspondence to like the song. So is that using a different process that's not just like volume, like the level?
It's probably using volume, but it's also using that thing that we talked about, which is a feature vector. So because of the feature vector, we actually have, we can actually determine mouth opening using that model. So it's not really looking at the audio, it's looking at how you manipulate FFHQ. Does that make sense?
Yeah.
Cool. It looks like I'm saving this out at the wrong bit depth. So let's change this to a bit depth of, I think 16 is probably what this wants. Yes, let's just rewrite it. So I will definitely say like playing with the audio in this is a little tricky. You have to make sure you're using the right bit depth. I generally find a WAV file works best as well. And I am also not the biggest audio person, so like I'm probably like hacking this thing together, but let's see if it works. There we go, cool. So this audio file is now giving us outputs, right? So we have, you know, essentially the vocal track here, and we can sort of see, you know, how it goes from high to low. Actually, let's see if we can play this. Let me know if y'all can hear this. I can't hear it. Okay, that's interesting. Were you guys able to hear it? No, okay. Let's try something else here. Let me just open this. No, the wrong thing. Let me try here. Nope, still nothing. Okay, give me 2 seconds here. I had this working yesterday.
And adding on to like the bit depth thing, in that it seems that the bit depth to use like the SciPy wave file reader needs to be 8, 16, 32, 64, 96, or 128. That's just like
Interesting. So I was missing. So it looked like I was at 24, which is one of those not supported. So, okay, cool. Let's see. Why is this not? Man, this is frustrating. Why isn't my audio working here? You guys hear that? Right, to hear that. Interesting. So why can't we hear these being played? Okay, well, what we'll do just to save ourselves some time here is clearly it's being read incorrectly. So what I'll do is I will upload our videos. Once we process this, I'll upload it to our Slack channel. We can check them out. But clearly something's working here, even though the audio in Zoom is just like always such a hassle. I don't know why. Okay, so next thing we're going to do here is we're going to import a bunch of code. And this is code you'll see if you dig into how you generate images using StyleGAN, you'll see this code inside of the code repos. But essentially what we have here is we have a generate a Z from a seed. So this actually takes that seed value, and this is how it generates the Z. So if you're ever interested in actually seeing what your Z value is, you could actually do like a print like Z and actually see what Z value is being generated from that random seed. This next chunk of code generates or converts our Z to W space. So if we have a Z space, we want to move it to W space, this code will do that. And then this last piece of code here generates our images in W space. So it's going to take our Z. So basically we give it a seed, and then our seed is converted to a Z. Our Z is then converted to W, and then we can generate an image in that W space. This is like, many people will tell you TensorFlow code is hard to read, and this is definitely like some of the harder stuff to read. I'll also say that the StyleGAN2 TensorFlow notebook is also like one of the more complicated things I've ever had to read. And many machine learning people who like do machine learning daily will tell you that like StyleGAN2 code is like very convoluted. I'm sure there's a reason why they did it that way, but it is, just be aware that it is kind of frustrating to read. Cool. Okay, so we're gonna run this cell just to save these functions into our setup here. Okay, so now the next thing we want to do is we're going to set up our network pickle, and we're going to establish a end seed value and a start seed value and an end seed value. So this first seed here is going to be the start. And then the other one is going to be our end seed. So we're going to go from our seed value of 75 to our seed value of 100 using a truncation value of 0.5. From here, if you just want to generate images, you don't need to read any of this code. You can, but like essentially what we're doing here is we're going to take these values, we're going to convert them to a Z value, then we're going to convert them again to a W value. And then what we're going to do is we're going to take that W value and we're going to map the volume, which goes from 0 to 1, to the values of our seeds. So at our first seed, our starting seed, if we're ever at volume 0, we'll use seed 75. If we're ever at volume 1.0, which is the loudest volume, we'll use seed 100. And then anything between there, we're going to get an interpolation between those two. So this takes that interpolation work that Leah was showing us and actually uses this to manipulate these things. So if we go through here, again, you don't need to, this is just basically generating, this is getting our W values. And then I believe here, yeah, here we're using a lerp function. So lerp is a linear interpolation function. And we are lerping from the starting point to the end point using the audio track and the particular frame that we're at. So again, remember that like we took a bunch of sequences of the audio track and we broke them up. And now at each one of those sequences, we're going to look for the volume at that level. And then we're going to do a lerp, an interpolation, and then we're going to generate an image there. So let's go ahead and run this command. And I have to tell you, like, if you're interested in sort of manipulating stuff in StyleGAN2 and you want to read through this, I don't touch a lot of these values. I'm generally generating the Z or generating the W, and then I am also converting, I'm generally doing an interpolation into these vectors. I'm not usually touching a lot of these settings. And I find if you do touch these settings, you generally like are going to break stuff. So just be aware of that. Again, this is sort of different than generative art, where like we're more or less playing with vectors rather than like trying to alter the network itself. You'll also notice that a lot of times when you first run a StyleGAN2 notebook, you get this, these two lines. So these two lines will sort of like slow you down a little bit. They'll take a little bit of time to get set up. There's some functions that StyleGAN2 comes with to help generate things quicker. And this is sort of what's set up. Once this is running, the first time you run it in a notebook, it'll require a little bit of extra time to get this set up. After that, it will run faster. So here we are, we're generating all of our frames. And if I go into my StyleGAN notebook, the way this notebook is, or the way I've set up this notebook is a little bit tricky. It generates a random number value and then it creates a folder named frames. This is so you could run this multiple times and not overwrite it. So just be aware that like you will want to sort of know what folder you're looking for. So I happen to know that this is the folder because this is the first video I've done. I'm going to copy the path for this. What I'm going to do is I'm going to paste that path in here. So while this is running, I'm just going to get it set up so that we're ready to go for the next. We're basically going to like take these frames, turn them into a video, and then add the audio back in so that we won't be able to demo it here, but I'll upload it to Slack and people can check it out from there. So this is going to generate the video. So again, we're going to take all that frame code. So if I go inside of here, you'll see frame 0, frame 00001. We're going to generate this into an MP4 using FFmpeg. And if you're familiar with FFmpeg, you can use different values here to get different bit rates or different like quality of samples. This is like a pretty generic, like decent quality video line. So I just generally will use this one. And also I want to change our frame rate back to 24. So I'm actually just going to run this. This one I've finished, but it'll get us, 200 frames of this. Oh, actually, I can't do that because I'm going to add the audio back in. So, okay, I'll sit here and wait for a minute. While this translates, let me walk you through. So basically what we're going to do next to finish this is we're going to generate the video from those frames. Then we're going to add the audio clip back on. So I actually realize I need to make sure that this is the right video path. And if I were doing this smarter, I would actually convert those using variables I've already passed in other places. But so it goes. So we're going to add the audio and video together. So this will generate our whole video. So once that's done, I'll run those two cells and I'll upload that. Now, I do have some other code examples here if you want to use other things. You want to use the volume to manipulate other things. So in this case, this is some code that can manipulate truncation. So similar to what we have where we're using 0 to 1 as our interpolation values, we're going to use 0 to 1 as our truncation values here. So anywhere where we have a truncation, or anywhere we have a sound or a volume of 0, we'll use truncation, a value of 0. Anywhere we have 1.0, we're going to use 1.0 for the truncation, and so on. One thing to note is that this runs very, very slow. Manipulating truncation values while you also are generating images will be like a quarter of the speed or I guess like 4x the speed of time it takes to generate these single images. So just be aware that like if you have a really, really long audio file, this will take a long time to generate because of how it creates truncation. So there's an example here of doing truncation. There's also an example here of using a feature vector. So if you're interested in playing with feature vectors, you can look at this. One thing to note is you do need I believe you need a .npy file. Yes, you need your feature vector file here. You'll have to create this. Generally, you can create these using GAN space. So if you go through that notebook, you'll be able to generate some of your NPY files, and then you'll use that. And all this does is it, basically, I believe the NPY file gives you a 512 dimensional vector that describes basically the path you would travel along. So what you do is you take your truncation value, so you take your seed value and you add, so you add the feature range into it. So you're basically like saying, take this and multiply it by this feature value, and this will do a feature. So if you basically have a feature
vector that goes from blue eyes to green eyes. This will give you at 0, you will have blue eyes, and at 1.0, you'll have green eyes. So this is the rest of this notebook. Yeah, so I recommend playing with this. Let me know if you're in any issues. I will say this is not set up as cleanly as I could. It was more or less thrown together for a couple different classes and just to sort of show people how you could do this. But I would love to come back and maybe add some additional GUI features to it to make it a little bit cleaner. Okay, are we almost done here? Almost done. Why don't we do this? So we've got 5 minutes left in class. I'll come back and generate this video once we're done. But I want to talk a little bit more just about sort of what you can do after this class. So I don't know how many of you are continuing on into either the next course or the following course, but maybe for some of you, this is your last class, which is great. I hope you enjoyed it. There is a end of class survey that Leah has posted, so I would love folks to take that. We really, really appreciate feedback on classes as we try to improve all of these. But if this is your last class, maybe you'll come back later, which would be great. But if you're not and you're just interested in more materials, here's some more materials to check out. So particularly for ML art, there are Runway, which is a class, I teach a lot on this app called Runway. Runway has a bunch of videos that also help explain, sort of how models that they have in their system work. Quite often those models exist in Runway, and you can also find them and create notebooks out of them. So any of the notebook conversion work we've done, you can pretty much take any Runway model you find and convert it to a Colab notebook. So they have some videos that explain the process of how to do things, and then also demos of how to do it in Runway, which can be helpful for you to convert a notebook in Colab. ML for Art is Gene Kogan's website. He hasn't updated in a year or two, but there's still a lot of valuable work inside of there. Gene was one of the early folks doing machine learning for art, and he has a bunch of resources on his class on this website, including a whole class he taught at ITP maybe a year or two ago. So definitely worth checking out. Gene also does all the videos for Runway, so he's just sort of one of those folks who we're into in this scene. And then there's Coding Train, which is Dan Schiffman's YouTube channel. He has a bunch of series on machine learning. It's not entirely machine learning only focused. There's also a bunch of stuff around generative art, but definitely recommend checking him out. And there are some cool machine learning stuff, materials in there as well. In case you haven't seen, there are other courses by Leah and I. These are probably the 3 that I would generally recommend people check out. AI 2.1 was a class we taught in January of this year, so still pretty recent. This is basically if you're getting tired of training on Colab and you want to try some new things, or maybe just train on a real server, this will go over how to train on a thing called Paperspace, which is a GPU-based server system that you can rent. This also goes a little bit more into Pix2Pix and StyleGAN. So we didn't really cover those a lot in this class, but if you're interested in learning more about those, this video series will go a lot more in detail into how those 2 work. The Runway ML deep dive class is if you are just really interested in playing with models, I definitely recommend Runway. Runway is an app that is a GUI interface for playing with things, has a ton of machine learning models in it. It's definitely fun to play with. I do a bunch of courses. Most of my intro courses are now in Runway. And Leah and I taught this class in March, something like that. So you can check out that course. And then I linked to 3 weeks of the StyleGAN2 deep dive this week. That shows a lot of the manipulation of different models inside of Colab. But the whole class is up here. So if you're interested in training, again, StyleGAN2 outside of Colab, there's a lot of materials on how to use GCP. I also go over all the various pieces of StyleGAN too, and how to do training. And I should also say I think we've got 2 or 3 more openings left. We're going to do a StyleGAN2 training class in October. So if you're interested in that, we do have a couple openings for that. Videos for those classes usually go up a month or 2 after the class is over. So if you can't attend that class, there will be videos at a later date. We're also doing a class next month that is on data sets and producing data sets, but that class is full now. So you'll have to wait for the video series to come out. And if you're interested in books or other materials, these are sort of the courses that I always recommend for folks. These are good if you're just particularly interested in machine learning and want to go maybe outside of the non-art world and just sort of learn more about machine learning. Fast AI, those are my favorite courses. 2 folks run those. a guy by the name of Jeremy Howard, and then another one. The woman's name is Rachel. I'm blanking. Rachel Thomas. So they have a whole series and a buffet of courses, and they are generally using notebooks for a lot of their stuff. So you'll learn a lot about different notebook techniques and things in there. The MIT Deep Learning course is a cool video series. This one doesn't get too math heavy. It still like sort of maintains like pretty high level and general level around AI. Sometimes they get into art or like vision techniques, and other times they like are mostly about deep learning. But it's still helpful to sort of watch this series. You'll learn a lot. Andrew Ng's Coursera course is like the most famous machine learning course I think on the internet. It is pretty good. It gets into very math and like theory level stuff, but it is still a really valuable course. And if you're not a video person, I think all three of these are videos. There are 2 books I generally recommend. Grokking Deep Learning is a new one I've really dug into recently. And it's really good foundational work around how deep learning works. So if you're interested in learning like PyTorch or TensorFlow and understanding how these models work, this is a good one to start with. And then Deep Learning with Python is Francois Chalot, who's just like a really amazing deep learning person. He wrote Keras, which is like a deep learning framework. And he does a really good job of explaining, this is mostly working with vision. So this is like pix to pix. You won't do StyleGAN, but you will do like DCGAN, some other things, as well as some text-based learning models. So if you want to play with like poetry, other things. I think his explanations are just really, really well done. And the code is fairly readable because he uses his framework library, which helps sort of obfuscate a lot of the issues there. These are the 2 books I recommend. I generally recommend Manning is sort of the technical company that produces a lot of these books. I find the Manning books are way better than like Pact Publishing or those other like sort of like O'Reilly level books. I find that these just have a general better sense of like explaining things as well as being able to like read the code alongside of them. Okay, so that's it for this class. I hope you enjoyed class. I will quickly go back and generate our video and make sure it's working the way you expect. There is an end of class survey, so please fill it out. We take all of your feedback really, really seriously. And especially if you hated this class, or you just found it wasn't what you expected, please let us know why, because we will try to update that in the future. I will say we've done like the past couple months have been us trying to do shorter classes. And I found the shorter classes are fun in that we see more people and we play with more things, but they're maybe not as good of a community building vibe for us. So I'm personally feeling like we might go back to slightly longer classes, but generally give us feedback about what you thought worked well and what didn't. And then lastly, we've got one-on-ones. So please sign up for those. You're paid for them. You're welcome to sign up for time to talk to Leah or myself. And those are just schedulable whenever. So you can set up, we sort of have our calendars there available when we're available. Yeah, and I think we might, I mean, Leah and I will chat, but like if you are interested, we can do another co-working session next Saturday as well. So we could sort of give people lots of time to hang out and talk with us and ask questions. Cool, so that's it for me. I see someone posted something in the chat. Oh, Adi has to head out. Cool, thanks, Adi. Cool, so let's go back, and before I take questions, I'm just gonna finish up this video and we'll see how this goes. So we've got our video here, so I'm just gonna generate our frames. All right, well, this generates any questions about either what we've shown today or class in general.
I have a question.
Nothing.
It's all
silent.
Am I silent now?
Okay. Well, we'll finish this video and then we'll see it and I'll upload it.
Right.
Yeah, and it was a really great class, everybody, and I hope you had fun. I hope you learned some stuff. And hopefully we'll see everyone in like one-on-ones or next week's co-working session.
Wait, Derek, I have one question actually.
All right, so it's just finished.
Oh, weird.
Download our video here.
Derek, I have a question. I don't know. Can you hear me?
Derek, can you hear us? Oh,
Eric.
Or, you know, I could actually use my snippets here and
No, you cannot.
wait. Here, I'll message him in Slack.
let's make this 640. Uh-oh. Okay, so there's our video. I'll upload this to our Slack channel. Hopefully that way people can actually hear it and see how it works. I will say that I find sometimes the lerp with volume does kind of some weird stuff, or it just like flickers between things, right? Because there's usually high spikes in these values. So you might want to do something like smoothing your values or something else a little bit. But I think there's some cool stuff that you can do with audio reactive. Maybe I can't hear anyone.
Yeah.
I'm just gonna go ahead. Go ahead, Peter.
Oh wait, so I had a question about it was kind of what I was mentioning at the. Can you not hear
Cool.
me?
So I'm just gonna shut up. I'm gonna let Leah field those questions since I can't hear anyone right now for whatever reason.
Yeah.
It was just with like the file or like folder structure and like pickle files. Because in this audio reactive notebook I saw, it was kind of the same thing versus the StyleGAN2 manipulation, where it just has like a network underscore like pickle equals, and then it gives you a space that's like / content FFHQ, where it's loading from like a pre-trained like set of pickle models. So if you're trying to insert your own in there, this is where I struggled last week because I was trying to give it my path, and then I also tried doing the ID. But how do you put your own model?
Okay. So you take your own model and upload it to Google Drive. Or yeah, so two options. You could take your model and upload it to Google Drive and then grab the sharing ID of it. Like if you go to you click your pickle file and click share, you'll get a link. That link will have an ID in it, and you can take that ID and let me share my screen. You can take the ID from Google Drive and then put it right here. And then that ID will be, it'll go to Google Drive and download your pickle file and save it as, in this case, ffhq.pickle, but you can name it like my network.pickle.
So it'll save it then.
Yeah, so that will download it and put it in here in your file system as mynetwork.pickle. The other thing you can do is you can try to upload it directly through Colab, which because the pickle files are really big, it might take a while. Like I've had instances where I'm sitting waiting for 20 minutes for my little orange circle to complete. But yeah, that's another option. And then it'll just be here as well. And then you can grab the path for grab the path and put it here. Yeah. Does that answer your question?
Yeah.
Okay, cool.
I have one question, which I know we didn't go into training in StyleGAN, but if you were to train, and if you want to download, I don't know if you can download a pickle file from Colab, or is there a way to put it back into Runway? Because you can take a pickle file from Runway and stick into Colab. Is it reversible?
It's not the most smooth process with trying to import models into Runway. There's not. Yeah, it would be really great if you could just upload a pickle file to Runway and it'd be there and you could use it. But Derek went through the process of putting one of his own models in Runway. It's the Munit faces model, which turns faces into plant flower textures. But because of I don't know, Runway kind of has this whole setup to like import a model, and you have to like run some of their code and get it in a format that can display in the Runway application.
Sorry, my audio is working now. So yes, that is true, but there is a way to bring in StyleGAN that's a little bit easier than that, but it's still pretty annoying, which I can send you the video on how to do it. I do a video on how to do it. But yeah, it's not my favorite process. It's still like, you have to like go to GitHub, you have to like clone a repo and then import your repo into Runway and then upload the pickle. It's definitely a process, but there are some steps to do it, and I can send you the video on how to do that.
I also have some last minute slides I added on what to do ongoing. This is a slide that contains links to a lot of people on Twitter who are pretty active in like posting things that, you know, are just cool. There are a bunch of artists here, coders. The line between artists and coders is pretty blurred in this space. There's also this creative AI newsletter, which I really like. This lady, Luba Elliott, she organizes a lot of like AI art, a lot of AI art like events. Like she's organizing the NeurIPS creativity workshop for this year and also previous years on like machine learning and art. And she has this newsletter where she just compiles like the latest that's happening and will get sent out like every 3 months. And there are a couple of people related to machine learning and music. Yeah, and also your second assignment is to go off into the world and keep learning from the resources that we've linked. And yeah, just play with the StyleGAN2 model. And yeah.
Yeah, and I should add, please feel free to use both our Slack channel, but also the general like artificial images Slack. There are lots of folks in there who have questions and will ask stuff, so you should feel free to jump in if you know the answer. Or if you have questions yourself, feel free to post in there. You're also looking to DM Leah and I going forward. Like, you know, there's no longer like there's no thing that like you have to stop talking to us now that class is over. We're happy to help where we can. We might be a little bit slower in responding just going forward, but happy to keep up with folks. And please, if you make cool things, like please add it to like the share work channel. I want to see lots of cool work, and I expect many of you will be doing cool things in the near future. So. Sorry for all the audio issues. Every time I try to do sound stuff with Zoom, something screws up. So got to go back and fix that one. That's another one for next class. So, but yeah, thank you everyone so much, and hopefully we'll see you all in one-on-ones and in the last co-working session. And I know we'll see at least some of you in like 2 weeks for the datasets class. So cool.
Yeah, and fill out the survey. We want to figure out how to make this better. Yeah, tell us your thoughts. It's really great having all of you. Thank you.
Yeah, it was great. It's great having everyone, and I hope to see you around Slack, the internet, and maybe eventually IRL when we can all leave our houses again. So cool. All right. Have a great rest of your Sunday, everybody, and hope to see you all soon during one-on-ones or in co-working or on the internet.
Thank you, everybody.
Thank
Bye-bye.
you.
Thank you.
Thank you.
Sure.